So let's see if I can get this right. So we're doing this. So I'll do both, but I'm probably separated into videos. So let me do the first sheet. Um, and let's see how I do this. All right, so again, our goal objective is to rewrite every expression so they have negative, positive exponents. Okay, simplify them. So this one, everything is positive. So 2 times 2 is 4, and m-fifth. That's easy enough. Here, there's a 1 there if you like. Put a 1. 2 times 2. 2 times 1 is 2. And 2m because we're adding the exponents, and 4 plus negative 3 is m to the first power. 8 r negative 3 plus r2 gives me r to the negative 1. Although there's nothing wrong with this, I want to change it so that I don't have to deal with any negative exponents. So the 8 I'm going to keep, and the r I'm going to put in the denominator, and that has an exponent of positive 1, right? Which I don't honestly need. So my final answer should look like this. Again, we're multiplying. 4 times 2 is 8, and then n, 4 plus negative 3 is negative 1. That's my final answer. That's pretty simple. Maybe it will be a short video. 5. 2 times 4 is 8. K to the 5th. That's ridiculously easy. Next one. 2 times 2 is 4. My coefficients. X third and x1 is give me x second. I'm adding them. Y to the negative third plus y to the third is y to the 0. Right? So, which I'm not going to write because that's just times 1. If I replace that with times 1, 4 times 1 is 4. So that, it's not that I don't want to write the 1. It just ends up being 4. Right? So actually, you know what? Let me just write it for now. And that eventually becomes 4 times 1 becomes 4x squared. 2 and 3, 6. And then x, y squared, vw, x, y, z. Write in alphabetical order. 4 multiplies with 1 is 4 times 1 is 1. V to the 4th power, u2. Next one, 4 times 3 is 12. A to the 3rd power plus a to the 4th gives me 8 to the negative 1st power, and b plus b2. So I keep the base, add the exponents. 2 plus negative 3 is negative 1. Again, nothing wrong with this, but our objective is to write it with all positive exponents. So the a is going to come down 1 to the 1st power, and the b is going to come down to the 1st power. That's my final answer. This one, x, okay, keep the base, add the exponents, so it's going to get x to the 5th power. And y, negative 4 plus 2 is negative 2. Again, I'm going to change that to x 5th, y 2nd. Okay. Why is this not deleting? Clear. So here we go. 11, it's just going to be 1. Anything raised to the 0 power except for 1 is 1. This one, again, remember, what's being raised? So it's everything inside. And if you want, put a 1 over here. So it's going to be 2 to the negative 4, right? Because 4 times negative 1 is negative 4. And x to the negative 8. Right. So we're using that. We're expanding the negative 4 to make sure that everybody's being raised to the negative 4th power. So it's a power to a power. So we multiply the exponent. So now we're going to make a few changes. I'm going to throw both of these fellows down here to the denominator. And then 1 over 2 to the 4th is 2, 4, 8, 16, x8. So this is my final answer. Let me just change this. 4 times r to the 0 power is 1, right? And then 4 times 1 is just 4, and I eventually get 4 to the 4th power, which is 4, 16, 64, right? 64 times 4 is 256. 64 times 4, yeah, looks like it's 256. 14, clear. So what you need to do is to make sure you raise this to the 2nd power and raise this guy to the 2nd power. So let me make this. So we got 4 to the 1st power, a to the 1st, and to the 2nd power. So remember, it's an exponent, right? So this exponent affects this guy, and this exponent affects that guy. So it's 4. 1 times 2 is 2. A, and we multiply the exponents. 3 times 2 is 6. And better yet, 4 to the 2nd power is 16. A6. That would be your final answer. Same thing, right? Remember, there's a little hidden 1 there. So it looks like this. You know, a lot of people forget to apply. So these two are applied to the fourth power. So 3 would be 3 to the fourth power, and k to the 16th power. Right? Can we multiply the exponents? 3 to the fourth is 3, 4, 3, 9, 81. Final answer is 81, k 16. 16. So now everybody here. So again, let me write this a little bit bigger. If you think about it, everybody has an exponent of 1, right? So if you multiply, right? So if you take that and expand, you get 4 to the negative 1 power, x to the negative 1 power, and y to the negative 1 power, right? Because this is multiplying. Now, if you notice, everybody has a negative exponent, so we're going to throw everyone down here. Everyone's going to have a positive exponent. And that's that page. Is there more? Yay, there's more. Oh. All right. So again, here, and this one, what I'm going to do is I'm going to just throw everything like this. Throw everybody to the denominator and then raise it to the 1 power, which eventually becomes 1 to e to the 4th, right? Because that 1 expands, it's just 1 raised 2 to the 1st power and d4th time, what do you call 1? These two multiply gives you 4. So the final answer is this. So you can do it that way, or the one where I did it in the previous problem. This one, 18, clear. Why is it not clear? So again, that x squared is raised to the 2nd power, and the y to the negative 1st is being raised to the 2nd power. So what I think I'd like to do is expand this. So 2 times 2 is 4, right? I get a 4 here. And negative 1 times 2 is negative 2. So after I apply the power, the 2nd power here to every factor inside the parentheses, I get that. But because the y squared, y to the negative 2nd power is negative, I'm going to change that and rewrite it like this. So that becomes this, right? Likewise here, I'm going to multiply first. So I'm going to get negative to this. I'm going to get something like that, right? Because there's a 1 here. X to the 4th times negative 1 is negative 4. And y to the negative 3rd times negative 1 gives me this. So what can we do here to get rid of the negative exponent? So I'm going to keep the y to the 3rd power on top, because that I'm not going to. But x to the negative 4th, I'm going to throw it down here. And that's going to make it into a positive. And 2 to the negative 1st power, I'm also going to send it down here. My final answer. Okay. Again, likewise, I'm going to do this. So remember, there's a 1 over here, and there's a 1 over here. So 1 times negative 2 is negative 2, and m to the 1st power times negative 2 is negative 2. So I end up getting this. Since they're both negative exponents, I'm going to throw both of these fellows down here. So I'm going to get 3 to the 2nd power and m to the 2nd power. Oh, numerator is 1. Better yet, it's going to be 1, 9, m squared. Where am I? Okay, so I'm going to expand this out so that you can see. I think it's nice when you expand it out. That's what I have. Now, this guy and this guy simplifies, so it's a 1 and 1, right? Divided becomes 1. This y simplifies to 1 and 1. So on the top, I'm left with 1, and at the bottom, I'm left with 2r. Right? This one, there's different ways of doing this. So let me rewrite this as this. So remember, it's division, right? Divided by 4x4. So if we follow the rule, hang on a second. I'll find an easier way of doing this. Actually, yeah. So here's what I'm going to do. That x, so I'm going to throw this guy to the denominator, right? So I'm going to make this. So on top, I'm going to have a 1 there, and then x to the 1st power is going to come down, times 4x to the 4th power, which I already had, by the way, right? It's already down here. Keep the 1 on the top, well, there's a 1 here, so multiply the 1 to 4, I get 4. And x to the first power times x to the fourth power is x to the fifth power. That's my final answer. I think it's easier if you see it like this. Here, I can cross this 3 into 3. That becomes 1. There's 3 ends at the bottom, 4 ends at the top, so this will have nothing left over at the bottom besides the 1, and I'm going to have 1 end on the top. Right? So if you think about it, you had 1, 2, 3, 4, 1, 2, 3. That's simplify, simplify, simplifies, and all I have is an n left over. M4, and again, I can simplify this. M4 divided by M4 is just 1, right? So on the numerator, I'm going to have 1, and on the denominator, I'm going to have that 2, 1 over 2. Okay, so I think it's better if you switch. So the m to the negative 4, I'm going to throw it down here next to the m to the third. Right now I have both with positive exponents. So there's nothing to do with the 3, so that stays. And m4 times m3 is m7. This one, ooh, yuck. So let me rewrite this one. I'm going to keep that. That's okay. The x is okay. But the y to the negative fourth power, I'm going to throw that y down here. I'm going to change colors. That's coming down. But the y to the negative third, who is down here, I'm going to throw it up. And that's going to be positive. The z, same thing. This z to the negative third power, I'm going to throw it down here. Make it a positive exponent. And the z to the fourth power doesn't go anywhere in space. Now I'm going to do some funny math. So the 2/3, not touching that. X second, x4, there's 2 x's at the bottom and 4x on top. So I'm going to have, if I cross them out, I'm going to have 2 x's on top. Y third, there's 3 y's on top and 4 y's at the bottom. So that means I'm going to have 1 y at the bottom. And z third times z4 is just z7. And that's not fun. 27, so let me rewrite this again. So I got a 4. X to the 0 is just 1. Y to the negative second power, I'm going to throw it down here. Z to the third stays up there. And I had a 4 and an x. Right? That was already down there. So let's do some cancellation. Well, 4 times 1 is 4. So I'm actually going to rewrite that just as 4. I mean, this guy and this guy can go away. And I'm going to have z to the third power on top. And that left over at the bottom. 28. Let's make some adjustments. 2h cubed, 3j, that stays, the k stays. And there's a j to the third power that I'm throwing down here. And the k to the fourth, that's already over here. Well, let's do it coefficient and letter by letter. 2/3, nothing happens. The h's, there's an h on top, there's no h's on bottom, so that goes. So this is gone, this is gone, this is gone, taken care of. The k, well, there's 1 k at the bottom, and there's 4 k's at the bottom, which means if I cross them out, I'm going to have 3 k's on top. The j's, there's nothing to simplify with, there are no j's on top, but they're simply at the bottom. I'll have to add them. Right? So it's a j, and there's a little 1 over here, so 1 plus 3 is 4. And that would have been my answer. 29. 29 is actually nice because I don't have to throw anyone anywhere. Up or down, numerator, denominator. So I'm just going to have to, like, 4/3. Look at the m's. One's m4, m2. Where are there are more m's on top, so I know that I'm going to have 2 m's left over here. And 3 and 2, there's 3 n's on top, 2 n's at the bottom, which means I'm going to have 1 n left over here. P4, there's 4 p's and 3 p's being multiplied on top, so these 3 p's will cross out with 3 p's over here, but I'm going to have 1 p left over. That's my final answer. Let me rewrite this. So we got 3x cubed, and let me deal with the numerator first. Y to the negative first power, I'm going to throw it down here. So this is gone. Z to the negative 1 power, I'm going to throw it down to the numerator. That's done. Now let's do this guy. X to negative 4, I'm going to throw it up here. So it becomes x to the 4. Y to the 0 becomes 1. And 0, what do you call it? 0 to 0 becomes 1. And I don't even have to write them. Because if I write 1 times 1, which is 1, and then there's a 1 here, an invisible 1, so it's just 1. So leave it like that. Clean it up a little bit more. YZ, I don't have anything to cancel. Simplify with the top numerator. But these two x's I can combine. The bases are the same, like the exponents, and YZ at the bottom. That's it. So that's the handout you were working in class. So now I'll make 2 different videos. They're not that long.